Hello everybody! In our lesson today we're going to talk about what uniform motion is. This is one of the simplest types of motion that we begin to study in the kinematics section. Our task today is to familiarize ourselves with this type of motion, to see what quantities we can describe it with, and what basic parameters exist to tell us what uniform motion is. So, uniform motion is a motion in which the body for equal time intervals passes the same displacement. Let's show this in the figure. So, we have a certain trajectory. Let's assume that the body moves in a straight line. We can divide this trajectory into several sections and choose them so that the body passes them in equal time intervals. Let's do this. The first section of its trajectory the body will pass in time t1. The second section t2. The third section t3. If these times are equal, and the displacement that the body makes during the corresponding time intervals will also be equal, then we call this motion uniform. Uniformity will consist in the fact that we can take any equal intervals of time. It could be a second, it could be a minute, it could be a fraction of a second. It doesn't matter. That is, our task is to show that in any equal interval of time a body goes through or makes the same displacement. And in order to now show how we can distinguish between different kinds of uniform motion, that is, some body may move faster, some body moves slower. In order to describe such motion, we can introduce a quantity which will show the rapidity of motion of a given body. Such a quantity we call the speed of the motion of the body. What is the speed of a body? In physics, we'll denote speed, or we can also call it velocity by the letters v, or such a v. By definition, for the traveling speed, we must define the speed as the ratio of the path to the time spent. And in this case, we get the numerical value of speed without specifying its direction. That is, we say that, for example, the car is moving at a speed of 20 meters per second. In this case, we measure the speed exactly in meters per second, because this is the system unit of measurement. Let's spell it out right away. And we will stick to this unit of measurement. Although, of course, we know that speed can be measured in kilometers per hour, miles per hour, and so on. That is, in the tasks, we will strive to adhere to a single system of measurement. But in the tasks, you can also meet another type of speed, which will tell you that it is required to determine the direction of this speed. The direction of that velocity. Here we are already saying that we will define velocity as the ratio of the displacement made by the body, again, to the time for which the displacement was made. We will be able to determine this velocity by the given formulas. And let's see what the difference turns out to be if we meet with different types of motion. For example, if a body is moving in a straight line and makes a certain amount of movement from point A to point B, and then returns back from point B to point A, then in this case we say that the body has traveled some path. That is, the path in this case will not be zero, because we see that the body moved and traveled some certain distance. If we denote, for example, with the letter L the distance between A and B, then we will have a path velocity equal to the ratio of the two L's to the time in which the path was traveled. That is L forward and L backward. But if we look at the velocity as we move, you'll see that the body no matter how it moved, eventually came back to its starting point. And it hasn't moved anywhere. That is, the starting point of the trajectory and the ending point of the trajectory coincided. In this case, the displacement would be 0, and so in this case we have a displacement velocity of 0. That's the big difference in these velocities. And you have to pay close attention to what velocity we're talking about in this problem. We'll definitely be looking at different examples of calculating travel speed, and we'll be looking at more interesting and more complicated examples in our future lessons. See you all soon.